All right, hello everyone. So we're gonna quickly go over the story description project you guys are doing that's due for the second project. First of all, this project is focused on this particular trip, which is the Ogden voyage, and this is in voyage ID 90473. All you need to go is you need to go to the transatlantic slave voyage, and you can go to the ship and nation owner. Excuse me, let me clear the annotation, and enter this particular ID, okay, as specified 90473. Once you apply this, you will be able to find this Ogden trip, okay, Ogden voyage. If you simply click it, you will be getting all the information about this Ogden. And what we are going to do is we're going to include, okay, basically generate a set that includes the Ogden and compare the Ogden trip with the rest of the trip in the same set. Since the Ogden trip is from 1973 to 1753 to 1754, so you can first of all do the year range, okay, that's between 1753 and 1754. And I will go ahead and remove the constraint of this voyage ID because that will limit down to 1. So in that case, you'll be getting around 506 entries. You're allowed to use other filters. Okay, this is just one example for illustration how you're going to conduct this descriptive stats voyage project. All right, so make sure the Ogden voyage is in it by checking on its ID. Okay, it's 90473. It's one of the vessel in this data set. Okay, once you have your filtered voyage, and make sure you are downloading the set, right? Downloading as CSV, okay, which can be opened in Excel. And also you need to pick 2 quantitative variable and pick 2 qualitative variables from this configure columns from there. Anyway, you'll be downloading the data set as CSV and filter results, okay, with the visible columns. If this doesn't work, you can always try the all results and check to see if that's what you need. All right. So anyway, once you have finished that, we'll be going to compare the Ogden voyage with the rest of the voyage, all right, in terms of, say, the region where the voyage began. This is one of the options for qualitative, or the principal region of slave purchase. How is Ogden compared to the other voyages in your set? We can also compare the quantitative variables, including, say, total slaves embarked, right, from Ogden compared to the other voyages. You can also compare how many guns mounted in this particular ship compared to the rest of the ship. Okay. So make sure in your output you are for including a frequency table, okay, for qualitative. Also try to get some graphs such as bar chart, okay. For quantitative variables, okay, make sure you are including the histogram and a box plot. It also talks about something about the z-score. So z-score is something we're going to quickly go over, which is try to compare the Ogden from the rest of the voyages in your data set. So here I'm going to talk about the z-score very quick. So z-score is going to be here very quick. A z-score is so-called a standard score. Okay, that's basically trying to find the relative standing of a particular data set. The z-score uses this formula. If it's sample, you go x minus x bar over standard deviation of the sample. Population, you go x minus the population mean divided by sigma. So the z-score always rounded to 2 decimal places. Okay. Important properties of z-score. A z-score is how many standard deviation x is above or below the mean, and that's how you interpret z-score. Z-score is a number without any units, okay? No units with z-score. It's just a simple plain number. A data value is significantly low if z-score is less than or equal to -2. It's extremely high if the z-score is greater than or equal to +2. So 2 standard deviation below the mean or 2 standard deviation above the mean. If z is negative, then the data value will be less than the mean. Okay, quick example. Which of the following two data values more extreme relative to the data set from which it came? 4,000 gram weight of newborn baby, okay, with X bar equals to 3152 gram and a sample standard deviation 693.4. So we need to find the z-score, which is X minus X bar, okay, divided by sample standard deviation. So you go 4,000, subtract 3,152 divided by 693.4. Okay, and you should keep 2 decimal places for this. So if you do the calculation, the z-score is 1.22, meaning this 4,000 gram weight is 1.22 standard deviation above the mean. Above mean. Okay. And similarly, we can calculate this 99-degree Fahrenheit temperature in this data set with X bar 98.2 and standard deviation 0.62. So its z-score is X minus X bar divided by S, which is 99, subtract 98.2 divided by 0.62. Okay, so if you do the calculation, we'll be getting 1.29 as for the z-score. So this is 1.29 standard deviation above the mean. So once you see these two z-scores, apparently 1.29 is more high. It's higher, right, than 1.22. So this 99 degrees Fahrenheit temperature is a higher score, relatively higher data from in its data set. All right, here we go. We got the calculation 1.22 if you want to refer it to. So this is an interpretation we just mentioned. Okay, z-score 4,000 gram birth weight is 1.22 standard deviations above the mean. 99 degrees body temperature is 1.29 standard deviations above the mean. And this 99 degrees Fahrenheit is going to be more extreme, okay, because of its higher z-score. And over here we have a table. Okay, if z is bigger than 2 or less than -2, then they are considered to be significantly high or low value. In between -2 and 2 will not be so significant. Okay. All right, secondly, if we do this question, the lowest count in a data set is 75. Is the value significantly low, assuming X bar is 239.4, standard deviation S is 64.2. Here we go, calculate the z-score, -2.56, and 2.56 is lower than -2, therefore significantly low. All right, now going back to our data set. First of all, Ogden trip, right? It has these values. For example, if I'm checking on the guns mounted, so guns mounted for Ogden is 8. Keep that in mind. So Ogden guns would be 8, right? And what we need to do, oopsie, is just let me get it back. Okay, I just need to clear this part of the version. So hold on, let me clear this portion. And once you got this, all we need to do is go to the StatCrunch and load the data you have downloaded. Okay, so I'm going to load the data that I have downloaded from the data set from the website. So here we go. You should have that on your computer, so just click the data. All right, that's what I have, and then just go ahead and upload. Okay. So, alrighty, well, for the sample illustration purpose, I don't think I have downloaded the Ogden guns as the variable. Make sure when you are doing that, you have your guns. Okay, if that's the variable you're checking on, make sure you have the guns in your one of the variables, right? It's okay if you don't have it. I'm going to actually look at another one. Suppose I'm looking at, let me see over here. All right, so interestingly, I think this sample I took does not have any of the quantitative, even though these are in numbers, but they're not meaningful, right? Captain's name, it's not comparable. So I need to go back to my data set to do another round. All right, so if you're going back to your transatlantic slave trade, right, make sure you are choosing the two quantitative variables. So suppose you're doing total embarked, okay, choosing that. And you're also checking on, suppose you're doing captives arrived. Captives arrived at a first port, or let's see the guns, right, by the ship. Okay, so the ship has guns mounted. All right, here we go. Now it has the guns mounted. All righty, and I have to re-download that data set. Okay, so filtered results with the visible columns, if that's what you want to have, right? Guns and total embarked. Okay. And this time I can reopen this data set. As a new one I just downloaded. And I would be able to see the guns this time mounted. Alrighty. So I do find my guns mounted column, which is over here, right? We do see lots of data are missing in this particular column. Okay, so that needs to be addressed when you are writing your report. And what we need to do is we just need to go to the stat and calculate the summary stats, okay, for this particular column for the guns. Okay, so guns mounted and compute. All right, we can see this number, and there's only 196 data value compared to actually, I think in my data set has around 506 data values. Okay. So we can see there are a lot of data missing, right? And anyway, for the mean of the guns mounted, it is 5.408. That is the average amount of guns mounted in this set of data. And for the Ogden, if I remember correctly, that has 8 guns. Okay. Standard deviation for the sample, right, will be 3.5267 right here. Okay. So we'll just go ahead and do xz equals x minus x bar divided by s. So we have 8 minus 5.4 divided by standard deviation, 3.52, right? 53, 51, and calculate the z-score for Ogden and describe whether it's above the mean or below the mean. Okay. So this is a little short demonstration of the video, okay? And I make sure for the other variables, such as the for example, if you have itinerary, or like where it is, where's the port, okay, those particular qualitative variables, make sure you are including the frequency distribution table and also the bar chart. Okay, so that's all we have today.